Okay, so I think I'm going to get started. So, hello everyone. My name is Bernard Lee. I'm one of the project administrators of the Ganglia project. So today I'm going to talk to you about Ganglia, which is a monitoring software. And the project has been around, for 10 years. So we're going to tell you about what the software does and why you would want to use it to monitor your computers, specifically, clusters, grids, or just web farms. So actually, before we begin, I just wanted to have a quick poll. So who has heard of Ganglia? Okay. So who has actually used it? Okay, so it seems like a fair amount. So maybe you guys know, quite a bit about it already. So okay, so well, actually, let me just briefly introduce myself. So, I'm Bernard. So I've been working on high-performance computing related open source software. So I've worked on provisioning tools like System Imager, Oscar, and monitoring side. Working on Ganglia. So that's for the past few years. That's what I've been working. Just getting involved with a lot of the open source software. So Ganglia, so what is Ganglia? So the goal is basically, this software is to gather system resource metrics in real time, and so that you can figure out what your host is doing. So you have even one host to hundreds to thousands of computers. You set it up and they're running, but you want to find out what a system resource is like and what it's doing. So when you have such a system, you want to have a software that gives you a centralized view of what's going on. So that's what Ganglia's goal is. So the project started around 1999 by Matt Massey. So it started at University of California at Berkeley. So it's part of the Millennium Project. So it's a project, that was involved with building clusters, and they want to find out what the clusters doing, how his system load is and things like that. So Matt wrote this software, and for the past 10 years, basically you think of monitoring for cluster, you think of Ganglia. It's somewhat become the de facto standard for monitoring system resources. So it's a very lightweight process. So when you monitor these systems, you don't want your monitoring daemon to actually take up a lot of resources, because that that will be very wasteful. You actually want to do real work on your computers. So if your monitoring software is in the way of that, that sort of defeats the purpose. So it's very lightweight in terms of CPU and memory usage. Doesn't use that much resources. And basically, you have a monitoring daemon called gmond, and you run it on every node. And there's basically all the metrics that's collected on each host is aggregated on a separate server, which runs the gmeta daemon. And these metrics are aggregated into round-robin database files. So ROD files are basically time slice data. So it's good for storing these metric data, so that you can go back in time and look at what your system has been doing in the past. Again, it's a very lightweight agent. It supports most Unix, Linux systems, and even Windows via Cygwin. So basically, the code you can run it on anything, and it doesn't matter whether you're running the Ganglia on these different OSs. They will all work with each other. So you can have a mixed sort of hybrid system, as in many large corporations you would run different OSs, and then you can use one tool to basically monitor everything. Keep pressing the wrong button. Okay, so it's BSD license, open source license. So what I'm going to talk about, so basically what you can do with this software, what does it look like when you actually use it as a user, and a bit about the architecture, and some advanced topics so by default Ganglia would collect 30 or so metrics about your host, like CPU load, memory, network, and all that stuff. So that's the default one that's collected by default. But if you want to collect your own metrics, like how your Apache server is doing, your memcached, or like just basically anything you can somehow collect from your operating system, you can plug these information into Ganglia. So I'll go into it a little bit in detail. Ganglia is very scalable, but so we're going to talk about some issues when you run into thousands of hosts or tens of thousands of hosts. And cloud computing is quite a hot topic nowadays. So just to give you some brief notes about what the environment is like if you want to use Ganglia to monitor it. And then we'll have Daniel Pocock just come up and give some user testimonial, and then basically I'll end with how you can get started and get involved with the project. So typical users, the project came about from high performance computing. So these are clusters of computers, basically have one goal, and it's just to crunch a lot of numbers, run a lot of parallel code, and Ganglia came about, and it makes it very easy to figure out what your cluster is doing. So it has this hierarchy of a grid and a cluster, so that you can find out if your cluster's doing, how your cluster is doing on one end, and then on the other clusters, you can sort of aggregate all the different data. And large enterprises, you have different servers like web servers, database servers. You have a large corporation that you have many computers that do different things. So you can use Ganglia to check how these servers are performing, and then you can go back in time, look at the history, and figure out what's going on. So it's pretty similar uses. And in your IT environment, you have support issues, and why is your system not performing as you think it should? So you can also use it to look at memory utilization, and when your servers reach a certain load, and maybe it's time to buy new computers or actually upgrade your memory or whatever. So you can use Ganglia to look at all these pretty graphs and give you an idea of how your systems are performing. And then you can see, okay, if a whole bunch of servers have really high load, maybe you can shift the load around and maybe even virtualize it. So. And you can use it to troubleshoot applications. So you have different users running different code on your computer, and maybe you're trying to figure out why is causing this. First of all, you need to know that your system's having high I/O load, but how would you tell? If you have 1,000 computer, you're not going to log into each one to do a top and figure it out. So with something like Ganglia, it's has this graphs with aggregated information. So basically you can see very quickly that what your systems are doing, and with that information, it helps you troubleshoot application problems and things like that. And when you're writing new software, sometimes you don't know how it performs, and you use it you don't know how much resources it uses. So again, Ganglia is useful for these kind of workloads. So just give you an example of some people who uses Ganglia. So these are just names you can find out from our website. There's a little bar on the side that tells you who uses Ganglia. So I like to point out especially about Flickr. So I know the previous operations manager, he was always say use Ganglia. What does he use it for? It's for capacity planning. It's you have these graphs that tells you, okay, well, we hit the resource wall. Maybe it's time to buy new computers. So you would go to your supervisor, your manager, and say, okay, well, this is the real load, and we need more computers to handle these loads. So it's good for that. So let me give you a quick demo of what Ganglia looks like. So this is, the Berkeley grid. So it's divided into different, so you see here you have a main grid. So this is sort of like the top level. It aggregates all the metrics you see at the bottom here. So this is one cluster, which you can click into. So this red line just tells you, okay, this is the number of CPUs in this cluster. And so, is the number of running processes here. This is the gray stuff is like the load. So there's a whole bunch of different type of charts that you can see. So it's like memory, network. So down here, these are individual hosts. So red here means it's sort of a high load, and green means it's not that busy. So again, you can click into it here and see what each individual host is doing. So this is one host. It says, it's been up since this time, and it gives you a lot of information. But so basically, all these metrics is collected on the host level and aggregated up to the top. So a collection of hosts is a cluster, and a collection of clusters is a grid. So you can actually even have like a grid of grids, so that you can sort of aggregate it all the way up. So these are stats of individual hosts. So it's pretty self-explanatory. Okay. Okay, so let's talk a bit about the architecture. Oops. So every node runs the gmond agent, so that's like what you run on an individual host. And so it doesn't keep any like historic data locally, so it's just, just the data just sent around. So the data is transmitted, so the metric data is transmitted by default, it uses multicast. So in environments where like multicast could be considered like chatty, like you don't want to send too many packets, what you could do is you can use, unicast UDP packet, so that reduces the amount of like network traffic. And then basically you have this gmetad server that aggregates all the data and stores it in an RD file. So I think I mentioned that previously already. And then all this information is then presented on the web server, which basically serves the web page you saw. And you install that web server like Apache or like Lightning or whatever, and you basically it runs on the same server as your gmetad process. And it's used to like create the graphs and the charts that you see. So let's just run through what it looks like. So by default, it uses multicast because it's very easy to set up. It's basically setting up is just just start the daemon. The configuration by default would use multicast. So every node would transmit its own metrics to the multicast group. So you don't need to do anything special. And every node would receive metric from each other. So essentially, you talk to one node, it would know the metrics information of the entire everything, every node from that multicast group. And it has again it just every node would already know like what the metric information of the other guys. And the node can actually be pulled by a specific port, and then it will give you like an XML sort of output of what like the metric looks like, and that's what we use sort of to send the information around. So then we have the gmetad server and the web server that aggregates all the data. So the gmetad server pulls in the multicast environment, it pulls any one of them. So if for those of you who have used it, in the example, it sort of alludes to that you have to add each host so there's a data source that points to like a particular Gmod host. So the configuration sort of alludes that you have to put every host in the multicast group, but it's not necessary because actually it's mainly for redundancy. So in case like if your multicast group, one host goes down, you can go to the other guys. But basically you just pull one host in the group and then you get, you'll get all the information of all the hosts. And so RD files are created and, to store the metrics. And then from the web browser, you can see the graphs and the charts and to see what your installation is doing. So I'm just going to talk about some advanced topics. So I mentioned previously, by default, Ganglia collects all these standard metrics, but what if you have your own metric that you want to collect that's not part of the standard metric? So we have this command line tool called gmetric that you can basically feed it metrics. And typically you run it, you either write a script that gets all this data, you write a program to get the temperature reading of your host, usually there's some command that you can run. And you would feed it to gmetric, and then your cron job would run it every couple minutes just to feed it the information. So in newer versions of Ganglia, we wrote a modular interface to Gmod, so you don't need to use gmetric anymore. So basically, you could write C or Python code that, and then the modules has callback, and basically, you set a value for how often Gmod would get the metric, and this is just snippets of code that you write to basically collect the data. So I'll show. I think the next slide shows you how it works. So in this case, you don't need to worry about having a cron job. So the Gmod process would be in charge of periodically getting all this information. So this is just a pretty stripped down example of what this modular interface looks like. So the first definition is basically what this does is it generates a random number and it feeds it into Gmod. So the first one basically does all your work. So back to the temperature example, you would write some code to get the temperature reading. And then you would init your metric and just feed it in. So the time max here is just how long it takes before you would feed it the data, and the unit here is it's just an integer, and it's actually pretty straightforward. So in the wiki page we have some document on how to write these modules. So so Ganglia is designed to monitor a lot of computers. So we noticed that when you have 1,000 computers, we start to have this scalability issue. So what the problem is that by default you have 30 metrics, and if you have 1,000 computers, that's 30,000 metrics. So each metrics, when it's collected, you have to write it out to RD files. So that means there's a lot of I/O happening. So previously, what we did was to put the RD files on tempfs. So it's basically just RAM. So it's really speedy. So that sort of alleviate the problem. So it could still continue functioning. But the problem is if you put your RD files in tempfs, then once the Gmod server reboots, then it's all gone. So you need to sync it to this so that you keep this historic data. So in the new version of RD2, there's a new daemon called RD cached. So basically what it does is it hangs onto write processes of these RD files so that it will hang on to a couple updates until a specific time has passed, or that there's enough updates, and it write it out at once. So in that case, it sort of buffers the write, so it reduces the I/O levels by quite a bit. So if you have if your Gmod is monitoring like over 1,000 hosts, then this is something that you can consider. So it's better than the TempFS approach because you don't need to sort of sync the files, and it's just a better, well-rounded solution. Okay, so I'm not gonna try to like give my own definition of cloud computing because there's already like so many, but I guess I'll just talk briefly about like how we as the Ganglia project want to address this. So basically for us, like Ganglia, the cloud environments are dynamic. So Ganglia was designed to monitor clusters and grids, which are pretty static. So you provision it once, basically you don't think of like it going away. It's just you just keep adding more hosts. So basically we need to figure out how to handle this dynamic nature. So in terms of like networking, there's no multicast support. So by default, Ganglia uses multicast. Obviously, you can use unicast, which I mentioned, but if you can't use multicast, it changes like how you set it up. And all these guys basically have like all these cloud computers. Basically, they have WAN IP addresses. So when you configure it, you need to, like for load balancing purposes, you need to have some way of bootstrapping the configuration. So you would maybe when your cloud host boots up, maybe it'll talk to a centralized server to figure out, okay, well, which host I should like send my metric data to. So these are some things that we need to think about. And in going back to the dynamic nature, so you have this host dmax, which basically tells Ganglia how long to hang on to a host. So in typical cluster environment, you actually do want to know when the host goes down, but then like because in cloud environments, you ramp up and ramp down like pretty quickly. So do you really want to like keep track of it that way? So basically, if the host dmax, you adjust it, and it just sort of ignores that the host is gone. So okay, so I'm gonna now hand off over to Daniel, who's gonna give some user testimonial.
Okay, my name's Daniel Pocock. I'm working at a large bank in London. I've been deploying Ganglia. I've also been involved with the Ganglia open source project for virtually the whole time I've been working on this project for my employer. So I'm currently working as the release manager in the project as well. I've been doing that for about 18 months. Using open source methods is a key part of the job. It's something that was discussed right at the beginning at the interview stage, and I indicated that this is a way that I work, and they were quite keen to pursue that with me. So we're just going to talk a little bit about both what we've done with Ganglia, the challenges we've faced, and also the aspects of working on an open source project in a corporate environment. So every big company has a different attitude to open source software, and you've probably seen this, that some companies talk openly about their involvement with open source and with Linux, and other companies are very sort of wedded to Microsoft in a big way. So there's obviously distinctions between the meaning of free software and open source software. In a business, and particularly in a bank, financial concerns are important. So we'll just talk about free as in no price tag. In the good old days, people didn't have to worry too much about the cost of software. And they'd often buy things based on the support contracts, the size of the vendor, and various other factors. These days, people are looking at a wider range of options. I don't think I need to go into the reasons behind that. But open source software is being looked at a lot more seriously. And where open source software provides like a credible alternative, people have to look at it. On the other hand, using public email lists, IRC chat, sharing code on the public internet, these create issues for many organisations. They create issues of how the company has been portrayed, like on the internet, the sharing of intellectual property. These are all challenges for different people in the company, some of them who are not from a software development background, to put it mildly. Ganglia has had it's provided a compelling reason to have those debates in the organisation where I'm working, and it has a relatively unique status, and we'll look at some of the reasons for that. It's not highly controversial because it's a monitoring tool, so it's not the core business of the company. The core business is banking and not system monitoring. So it's not a big loss if if we're collaborating on a system monitoring tool. So we can do that with the Ganglia project quite effectively because of the modular nature of the project. As Bernard mentioned before, with version 3.1 of Ganglia, you can develop your own metrics as modules in C or Python. And you can feed metrics in with gmetric. So if we have a need to develop a metric that uses proprietary code, we can do that, and that code can be separated using the module interface. So if we want to share parts of the common agent code, as long as that module interface is stable, then we can separate those things very easily. Just looking at the large enterprise environment, you've got a mix of different platforms. You've got platforms from different generations. So you have some machines running recent versions of Red Hat. You'll have other machines running, say, Windows NT4, for example, which is quite an old system. So if you look around in an organisation that's large enough, you will find a little bit of everything. I mean, you'll find mainframes if you look around. The users have a whole range of different concerns. They're particularly concerned about something that might make their system less stable, that might steal resources from their application, or that might add complexity to managing their hosts. Fortunately, the Ganglia agent is lightweight. It runs on many of the platforms in a big environment. The source code can be tweaked if necessary because it's open source. So if we have a particular need, we can recompile it for a particular platform. If we don't want to use a particular library or something, some of the libraries can be disabled. So the PCRE support, which has been added recently, is a purely optional feature, so we can disable that. Some of the challenges that we face using the Ganglia product in particular, it's heavily reliant on DNS. Once again, big organisations have a range of DNS problems. They're not connected directly to public internet DNS servers. If you've had a lot of mergers and other corporate activity, then you may have several different DNS zones within the organisation, and they might be separated over different firewalls. There may be overlapping IP space and a whole range of things. Now, Ganglia relies on reverse DNS lookups, and it relies on the host names to generate file names for the graphs. and to generate the URLs for looking at those graphs. So when you have a lot of DNS-related issues in your network, then those will be reflected in how you manage Ganglia. It's not clear how Ganglia is intended to perform with short polling intervals. While looking through the gmeta code recently, I found some cases where poll intervals have been randomised by 5 seconds either way. But if your polling interval is, say, 5 seconds, and you randomise by 5 seconds, then you could reduce the interval to 0, or you could increase it to 10. So I found that wasn't very effective, so we decided to tweak some parts of the code to handle that, but there may be more attention needed to deal with that. You've seen the example before with the hosts grouped into clusters and grids, but when you install the Ganglia package on the host, how does it know which cluster to join? The current version of the agent is configured using a static text file, so you can include a text file in the package. You can also use a tool like Puppet. If you have a Unix platform and you have Puppet across your whole network, you can use that to join different hosts to different clusters. But in an organisation that has Windows and that has some hosts that are quite old, deploying Puppet would significantly magnify the effort of installing Ganglia, because then you've got to install 2 products and not just one. So that's another challenge that we're looking at in the Ganglia project. To run Ganglia on Windows, you currently need Cygwin. The good news is, using Cygwin, it does work, and it's quite effective. The bad news is that there are issues with having multiple Cygwin applications on the same host. So once again, if you've got a lot of Windows hosts, and if some of them have been around for a long time and some of them are quite new and they're all running different applications, you may not know if some of them already have Cygwin. And so when you put the Ganglia agent on there, you could break something else. So once again, the Cygwin DLL is a challenge that we need to deal with. With the project that I've been working on and participating with the open source community, we've been able to discuss many of these issues and to find ways to manage them. Some of that work has been contributed back to the open source project. So I'll just bring Bernard back now to wrap things up, and then we can go into some questions or some further demonstrations. So.
Hello. Okay, so, thanks, Daniel. So how can you guys get started if you want to try it out? So I guess the easiest way to just use the prepackaged stuff. So the Debian packages like Red Hat, Fedora, SUSE. I mean, they're all been around for some time. And even on Solaris, I think recently Daniel did a lot of work. Well, actually, it works now, right? The OpenCSW. So you can get it for Solaris even. So yeah, as I mentioned before, even though you have different distributions, you just install the packages, they should just work. The only issue is sometimes with the free one version, you can't really mix it with free.0, but that's just some subtle issues. So yeah, again, just install Gmund on all the computers you want to monitor for metrics, and dedicate one server for Gmetad and a web server, and basically you're done. So in theory, you don't really need even a configuration file for Gmund, but you can use it if you want. So if you want the bleeding edge stuff, or somehow there are no prepackaged packages, then you can download the source tarball, or even from our repository, and then just build it. So website ganglia.info, you can see what we've been doing, and there's a wiki and a SourceForge webpage, and we provided this framework for you to monitor your systems and also these custom ways of like feeding these metrics. So there actually is a community around it to sort of write their own metrics, so you don't have to reinvent the wheel. So there's people writing, as I mentioned before, like monitor Apache or Memcached, or there's a whole bunch of like these custom metrics that has been created already, so you can check it out before you write it. So finally, there are a couple mailing lists, Ganglia General, these are all hosted on SourceForge. Ganglia Developers is the developer mailing list, and we are on RC Freenode. There's a Twitter sort of aggregation feed, and so actually one group of people I'm particularly interested in inviting to sort of join the project is, I guess you've seen our front end. I mean, it's been like that since probably the past 5 to 10 years. I mean, it's pretty functional. But as the project goes on, what will be nice is a way to customize what you see on the front end. So there's already work done to make the front end more modularized so that you can customize it, because depending on your company's organization, some group of people may want to see like your Ganglia graphs in one way, and then another group may want to see it different ways. So it would be nice to sort of provide some mechanism so that it's very easy to customize without even like writing any code or anything. So if there are any like Ajax or sort of JavaScript gurus who are interested in working on a front-end project, let us know. So I think with this, I'd like to thank Daniel for helping me prepare the slides. I mean, he did all the stuff, and thank you FOSDEM for inviting us to give this talk. So thank you. So I think we have if you want to have any questions.
Maybe I should be looking at the mailing list, but we're using Ganglia with IPv4. Are there any issues moving to IPv6?
Sorry, say that again.
We're using Ganglia with IPv4.
Okay.
Are there any issues in moving to IPv6?
You said RX. Okay, sorry. Let me just.
Are there any issues on moving to IPv6? Have you seen installations using IPv6?
IPv6.
Yeah.
Actually, that's a very good question. I'm not aware of any. I would assume that as long as your network, your operating system supports it, I'm not sure if we need to make any modifications to the code, because it's just. Actually, does anybody? You guys know? Have you guys? Yeah. So. Yeah, maybe we can take this offline, because I'm not aware of anybody sort of needing this, use yet, so.
I know V6 does at least somewhat work because it broke BSD fairly badly when the port went in, so I know it's in there.
So, like you're saying that it works with Ganglia just by default? Yeah. Okay. Yeah, because I haven't tested it. I actually haven't seen much traffic about it. So, but I mean, definitely try it out, and if